Welcome to The Explainer. Okay, we've got an absolutely incredible journey ahead of us today. We're going to be synthesizing a massive wave of summer 2026 updates from four of the world's leading scientific institutions. We're talking NASA, the European Space Agency, CERN, and MIT. We are taking all of this groundbreaking data and weaving it into one cohesive, guided itinerary for you. So if you love understanding how the absolute cutting edge of human knowledge fits together, you are in the exact right place.
Here's our itinerary for today. 4 quick stops. Number 1, looking up at space exploration. Number 2, looking in at particle physics. 3, looking forward to future tech. And finally, number 4, looking down at Earth science. All right, let's dive right into part 1, looking up space exploration. Millions of people are gearing up for some immediate excitement. On August 12th, 2026, a total solar eclipse is passing right over Europe. And hey, if you aren't in the path of totality, don't worry. Both ESA and NASA are fully mobilized to bring this right to you. They're providing essential live coverage, virtual totality experiences, and crucial skywatching tips. It's just a powerful reminder of how these massive celestial mechanics can captivate all of us at the exact same moment. Now, while we watch our own sun, the James Webb Space Telescope has basically blown the lid off a stellar treasure chest. It's capturing these unprecedented views of star formations and actually mapping out the family trees of newly discovered, incredibly distant objects. But it's not just looking at the deep past. JWST is also tasked with studying our own local neighborhood, preparing to look at the recently identified asteroid 2024 YR4 to get a highly accurate estimate of its size. And speaking of asteroids, that brings us to an absolutely pivotal moment in space exploration. Just listen to this mandate from ESA regarding their Hera mission. Humans changed an asteroid. Now we find out how. I mean, wow. We are officially moving past simply observing the cosmos to actively interacting with it. Hera is heading out to analyze the aftermath of our planetary defense tests, specifically how we intentionally altered an asteroid's trajectory. Understanding exactly how that rock responded is absolutely critical for humanity's future survival and our ability to protect our pale blue dot from incoming threats. So we've been looking up at the infinite cosmos, right? Manipulating massive rocks hurtling through the void. But what happens when we take our focus and zoom all the way in? Let's completely pivot from the massive cosmos down to the infinitesimal subatomic world. This duality in modern science is just staggering when you think about it. On one hand, we build these monumental, massive telescopes with NASA and ESA to peer across literal light years. And then, on the exact opposite end of the spectrum, we construct massive underground rings at CERN, speeding particles up to the speed of light just to smash them apart and see what invisible microscopic secrets spill out. The physical scale is completely opposite, but that profound sense of awe, it is exactly the same. Which brings us to part 2, looking in, particle physics. To really wrap our heads around what's happening at CERN right now, we need to lock down one absolutely crucial term, and that is luminosity. Now, in particle physics, luminosity isn't about brightness. It's actually the number of particle collisions happening in a given amount of time. Right now, CERN is in what they call Long Shutdown 3. They're upgrading the Large Hadron Collider to the high luminosity LHC. Their new generation of incredibly powerful quadruple magnets just reached full power in testing. And the goal? To increase the number of collisions by a factor of 10. That's going to give physicists a vastly larger data set to hunt for totally new discoveries after 2030. And we really need that massive amount of data, because some of the universe's oldest mysteries still aren't fully solved. Take the elusive neutrino. It's just wild to think it was theorized back in 1930, but took 26 years just to prove it even existed. Today, on the 70th anniversary of its discovery, it is still stubbornly keeping its secrets. This 70-year puzzle just continues to inspire major, ongoing global research efforts at CERN today. But CERN isn't just out there hunting for elusive individual particles. They are pushing boundaries to literally recreate the genesis of the universe itself. We are now 1 year on from the first ever collisions of oxygen at the LHC. And the crucial point here is that these oxygen collisions are showing new indications of an extreme state of matter. These experiments literally explore new ways to mimic the exact conditions of the universe in the first microseconds after the Big Bang. It is absolutely astounding to think we can recreate the dawn of time inside a tunnel in Europe. Now, all these quantum rules being uncovered at CERN, they don't just stay stuck in the realm of theory. They directly inform applied materials science. Researchers over at MIT are taking quantum behavior and turning it into tangible technology.
They've just produced air-stable, ultra-thin, wafer-scale superconductors. Previously, using these materials in quantum tech hit a massive roadblock because they were unstable or just way too hard to mass produce. MIT's breakthrough means we can now manufacture them reliably, paving the way for truly scalable, practical quantum computing devices. All right, let's move forward and see how this builds into part 3. Looking forward, future tech. The sheer volume of output coming from MIT this summer is honestly staggering. I mean, in just a matter of weeks, they've dropped AI for personalized stroke rehab, hundreds of new cancer models, a fundamentally new recyclable yarn. The speed of simultaneous innovation happening right now is absolutely breathtaking. Actually, scratch that. I want to slow down for just a second and anchor on this one vital number right here, 600. MIT scientists have just unveiled more than 600 new tissue models of human cancer. And these aren't just abstract simulations, right? They are derived directly from actual patient tumor samples. And most importantly, they are being made available to researchers all around the world. This is a massive, globally shared resource designed to accelerate the development of new, life-saving cancer treatments. Switching gears a bit, let's explore a truly brilliant example of elegant engineering. MIT researchers tackled the massive waste problem of stretch fabrics by designing a recyclable elastic yarn made from polyethylene. The process is amazingly simple on the surface. You spin a spool of the yarn, you melt it down, and you simply respin it into new yarn. And the incredible part? Even after 10 recycling cycles, it remains just as strong and flexible as conventional spandex blends. That is a massive win for sustainability. Okay, our final stop, part 4, looking down, Earth science. So, sticking with MIT for a second, they've developed a new hydrogel inspired by how human lungs move oxygen. It is roughly 10 times more breathable than conventional materials, allowing heat and sweat to easily escape. And even more impressively, it retains 95% of its airflow even after being stretched 10,000 times. This has massive implications for the future of wearable technology and medical devices right here on Earth. But our technology isn't just about what we wear, is it? It's about monitoring the health of the planet itself, and space agencies play a massive role here. Recently, ESA satellites, part of their Earth observation programs, captured some pretty startling images of Europe's major waterways. Specifically, they recorded the Danube River's waters falling to absolute record lows. ESA's satellite network acts as this impartial orbiting planetary health monitor, giving us the unvarnished data regarding the real-world environmental impacts of our shifting climate. And here is where we find the real so what factor of all this orbital infrastructure. NASA recently highlighted how their TEMPO mission data is actually being utilized down on the ground. This atmospheric data isn't just sitting on a server somewhere for elite scientists. Local educators and teenagers are getting hands-on with the TEMPO satellite data to directly investigate the air quality in their own specific neighborhoods. It empowers local communities to really understand and monitor the very air they breathe every single day. So, let's pull all of this together. We've mapped out a pretty vast scientific itinerary today. At the macro scale, looking up into space, we are interacting with asteroids and getting ready for eclipses. Down at the micro scale, looking into the quantum realm, we are recreating extreme matter from the Big Bang and building scalable superconductors. And finally, at the human scale, looking down at Earth and forward to future tech, we are tackling everything from cancer research to sustainable materials and climate tracking. Each scale of discovery collectively pushes human knowledge forward. And I think that leaves us with one final, pretty profound thought. When you step back and look at the sheer velocity of innovation happening across ESA, NASA, CERN, and MIT just in the summer of 2026 alone, it really makes you wonder. As we relentlessly uncover these secrets from the infinite expanse of the cosmos all the way down to the infinitesimal quantum realm, what paradigm-shifting discovery are we going to make tomorrow? Thank you so much for exploring with me today, and